We've been working on wearable robotics for many years. One thing we've realized is the importance of optimizing or tuning the assistance to different people. So really personalizing assistance. And the reason that's important is we all move and we walk a little bit differently. And that's even more important in patient populations. And we have a project at the moment where we're trying to help stroke survivors walk better. So for example, we're working on approaches to estimate walking speed and also kind of symmetry. So what's their healthier leg doing versus their less healthy leg? And then by having those metrics that we can estimate from the wearable sensors in the robot, we can kind of then encourage the device to help a person walk in a more natural or more normal way. A lot of students in our group now are taking data science classes or machine learning classes, and their ability to kind of go from data to kind of like using a model to kind of estimate or predict something, that has really just accelerated a lot. So it's kind of much more accessible as a tool for us as researchers developing wearable technology. And at the same time, there's the ability to also embed those and run those in real time as part of control loops. So people call that tiny machine learning or on-edge AI. But now a lot of the computation and the processors have got better so that we can actually run these more complicated models in real time as part of a control loop. Research in our field is always changing. I think when we started our research group, 14 years ago, I think we were largely a hardware-focused research group where we were building robots that were soft, that could help people move better. And as we have moved that part of the field forward, and others in academia and industry as well, now we're at the point of how do we leverage all the data we can collect from these devices? And how do we kind of use that data to make these devices perform even better? So it's been exciting that we're kind of shifting away from being more of a hardware-focused group, where now we're kind of like leveraging data and using kind of unique types of sensors and using machine learning and AI to not only kind of make our robots work better, but make it easier for people to interact with these robots, and sometimes also have a behavioral intervention that goes along with the robotic device itself. So it's really thinking about full service assistance from a robot, and that could be applied to workers in industry. So not only can we offload their back with the robot, but we can give them guidance on whether they're lifting safely or not. Or for a stroke survivor, if we're kind of personalizing a device to help them walk better, we can also give them metrics and they can see that themselves, or maybe even their clinician or therapist can remotely monitor how they're doing. And so we're using data, using machine learning, using AI, not just sell a product, but more sell a full service that can kind of really hopefully help people move better. If people can monitor how they're moving, and we can give that feedback to them, we can encourage them to move better or more using the data that we're collecting with these wearable sensing systems. So we're going to have like more and more wearable sensors that monitor either our heart or kind of our motion. But the question is kind of what was a person doing at that specific time? And this is really important for a variety of applications, because if you just collect data from a person 24 hours a day and you don't really know what they're doing, how do you kind of make sense of that data that you're collecting if you don't really have that context? And so I think kind of using AI, there's a big opportunity to really understand kind of like, well, what activity was a person doing? Were they walking? Were they going upstairs? Were they lying down? Like if we have that context information, I think we can better interpret and make sense of all the data that we're going to be collecting. So that's one thing that we're quite excited kind of like for going forward is kind of, can we use AI, can we use machine learning to understand the context of what a person is doing, and then use that as a way to kind of better kind of design either kind of behavioral interventions or kind of wearable robot interventions as well. And so kind of a physical therapist or an occupational therapist is a really kind of critical part of a person's recovery, say after a stroke. And so they're going through some rehabilitation regime, and it's generally accepted that higher dose is better and higher intensity is better. But there's no way that you can have a therapist with you all the time. And there's no way that insurance is going to cover kind of like lots and lots of sessions. So we see AI kind of and building AI agents in that space as a really exciting opportunity, where now a therapist is able to kind of like work with a patient and have some asynchronous activity with an AI agent that they control and they use to kind of help a person kind of perform their rehabilitation. And then they can still see how a person is interacting with that agent. They can kind of collect data from that interaction and kind of personalize how exactly that agent should best help that person. So we really see AI agents as kind of going to be a real tool for therapists, but it won't completely replace the therapist. It'll be more something that augments their ability to see more people more frequently.